Good afternoon and welcome to this installment of our BIC web seminars. Today's topic will be a deep dive into the world of dispersion. With us today, we have Andy Stummer, our business line manager for dispersion. He'll be presenting, followed by some Q&A. So if you have any questions at all, comments, concerns about your facility or what materials you're using, please log them in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them concluding the presentation. My name is John Kowalski. I'm part of the marketing group here. We will also be recording this, and we'll send out that link tomorrow morning for your review or to share with colleagues. So with that, let me present Mr. Andy Stummer. Andy, it's all yours, sir.
This is part one.
Sorry, Andy. Andy, sorry to interrupt. Would you mind starting over? I just unmuted you here. I realized I had to do that on my end. Here we go.
Thank you, John.
Thank you.
Hello, everybody. Thank you for joining today for the dispersion deep dive, part one. We're going to discuss the pre-dispersion process, and in some weeks we have the second part. So I start out with an introduction. We'll discuss some various lab equipment and production equipment capabilities. Also QC, and then we're going to show you some lab capabilities that we have here in the U.S. in Wallingford with our sister company, the Big Additives Group, and also at VMA in Germany. As you can already see on the slide, we have dissolvers from very small laboratory scale all the way up to production, and many models in between for different applications. So the company was founded actually in 1972 by this beautiful couple, the top right. The gentleman is Mr. Hermann Getzmann with his wife Elke. They founded the company in 72 in Germany, about 30 miles out. Believe it or not, I know customers in the U.S. that imported those units in the early 80s, and they are still running the original Dispermats from back then with the original. The mid 80s, and then we decided that we would also to the product line. Years ago, we started to also introduce the production line of dissolvers and milling equipment. So we are now offering the entire. So you can see the old building is in front, and the new building that was added on with the capability of lens, and there's a new area as well as a new design center, and they have people now designing new equipment. One of the interesting things about the product line is that 40% of things via mix is custom. So we get a lot of customers that materials. So they may accommodate those requests and really meet all different. We have a beautiful have at Wallingford with Big Additives. And we dive right in. So we want to talk about the dispersion. So we have different type of pigment classes. So organic pigments, and we all, and then obviously it's a very popular type of dispersing parameters because you don't want to destroy
Hey, Andy. Andy, let me interrupt for a minute there. We're having some problems with the audio. It's breaking up on you. I'm not sure if you can disconnect your audio and reconnect it. If that would be a possible thing, hang up and call again.
Let's try that. Hold on.
I think. Okay, thank you, sir. And thanks all for those who put in the chat that we're having audio connection issues. So thank you with that. You know, while he gets reconnected here and we get things settled, if you have any dispersion questions, please log them in the Q&A box located in the bottom right-hand corner of your screen. Yes, Andy.
I'm back. Is the connection better now?
Yes, for me it is. Everyone in the chat, can you give me a thumbs up or yay if it's better? Okay, much better. Got that. Thank you.
Hello. Sorry about that. I'm not sure. Sometimes we have issues with the audio because I'm calling into Wi-Fi with the presentation. So I just dialed in again. I hope this is a much better connection now.
Yeah, I'm getting everyone's saying much better. There you go, Andy. Thank you.
All right. Thanks for everybody's patience. Appreciate it. So anyways, we're going to look at the dispersion process, and then what's very important there is the types of pigments that we're working with. So we have the organic pigments, the inorganics, the functional pigments, and then obviously the special effect pigments play a role there as well. It's important to understand that we can't really destroy them, so the dispersion parameters are obviously different when we're dealing with special effect pigments. Why are we doing this dispersion process? It's important because we want to have a much better color strength, color stability, gloss, as well as transparency. Improvements are critical, and the cleanliness of shade as well. So these are just some of the core parts that are really important and why we are doing dispersion to our pigments. So better wetting, breakup of these van der Waals forces. These are these binding forces that hold the pigments together. We want to be able to reduce them ideally to the primary particle size. The smaller my particles, the better my color, much better improved appearance, better gloss, and improved pigment efficiency is also an important one because the smaller I go with my milling, dispersing, the less pigment I have to use. So I'm much more efficient. That also means I can put in less material, so that helps me with my cost savings. I will have also much better product consistency with proper dispersion. My formulation is obviously going to be improved. I also will have a more consistent particle size distribution and better upscale results because of that. Some of the issues that are occurring if I do improper dispersion of my pigments are obviously poor color stability, could have color change as well. My pigments will flocculate. That's obviously one of the big areas that's a critical problem. Sagging, leveling, settling, everybody knows those. Reduced gloss levels is another big issue that comes up from improper dispersing the material. And then at the end, some separation issues also occur. So it's really important to have a good process in place for better dispersions. So that will give us much better stability. So the pigments require strong color fastness to reduce fading over time. That's very important. Our brightness needs to be improved. This will also give us the best possible color that we get out of the pigment. Our pigment size is very critical. So the rule of thumb really is that the smaller my pigment, I have improved transparency and better color. And also I'm able to reduce my costs because I'm using less pigments, as I mentioned before. And then lastly, the viscosity is important because the lower my viscosity, the better I can make my product. And also I have an improved particle size distribution as a result of these better processing parameters. So it's very important to remember when we talk about dispersing that it's a particle size reduction only and not really a destruction of the particles. So what we don't want to do is we want to destroy our pigments with the shear forces. All we want to do is we want to really break up these binding forces that hold these pigment clusters together. And that's what we really want to do. And we use the shear forces to achieve that. And these are really responsible for that separation to break up these binding forces. Then at the end, when we achieve that, we want to use additives to basically keep our primary particles or aggregates, depending how small we go down, in a suspended state so they don't settle out. That's the last part. That's the most critical component in the dispersion process. And here is a slide just showing you different types of pigments. So you can see the TiO2s, the yellows, all of these, ideally, we want to break down to primary particle size to get those properties that I mentioned before. So the dispersion process is really the separation of these binding forces when we start out with these pigment clusters. So imagine you have these tiny pigment primary particles, and they basically get drawn to each other, and they create these larger clusters of agglomerates. And the goal is to really break them back up and turn them into smaller particles, clusters. These are the aggregates. And the step that is needed to achieve that is actually the first step in the dispersion process, which we refer to as the predispersion process, where we use a dissolver to really break up these binding forces and turn these agglomerates into the aggregate state. If I want to go over to the primary particle state, I really need to introduce additional shear force because the Couch blade is no longer sufficient. I need to do media milling. That will help me turn the aggregates down into the primary particles. So the first step is the wetting of my solid particles as I'm introducing them into the fluids, and then the mechanical breakdown of these agglomerates into aggregates, and then with the milling equipment into the primary particles. And then at the end, we want to stabilize them to keep them in the suspended state. So this is a great slide. You can see right here where we have our dissolver disc, and then we do the wetting, grinding, so the pre-grind, and then at the end, if we're going to go down to the primary particle size, we need to do the milling, and that will allow us at the end to keep the particles as small as possible and in a suspended state by putting in the right additives to achieve that. So then we have this slide showing you exactly the limitations of the dissolver and when we would need to start the milling process. So the dissolver is our first step in the whole dispersion process. And it is required to really break up the binding forces of the agglomerates, turn them into aggregates, and achieve at the most about 10 microns of particle size. You can't really go any lower. Mostly we see that the limitation is between 20 to 30 microns of particle size. If I want to go any smaller, I really need to introduce the milling systems to my process. If I want to go smaller than 10 microns, or even into the nano range, there's different types of milling equipment that's on the market, as you can see right here. So for my fine dispersing, I have my vertical bead mills, my basket mills, my horizontal mills, which we'll be discussing at a later time when we dive into the actual milling component. Today, we're going to talk more about the predispersion part, what we use the dissolvers. And there we have a variety of different products that allow us to achieve very good results. So the most important number that you should write down is the predispersion tip speed between 18 to 25 meters per second. That's the ideal window of where you should be in order to achieve the optimum breakup of these binding forces. When we are milling, we're looking at about 10 to 16 meters per second, so it's a little bit lower speed of our milling disc or roller. But when we talk about the predispersion with the dissolver blade, we should be between 18 to 25 meters per second of tip speed for optimum results. So we also want to look at the diameter of our milling or dispersing blade, and it has to be about 1/3 of our container diameter. That's ideal. We have some flexibility there depending on our viscosity of our product, our rheology, how does it flow, and basically we can make some small changes there to optimize the flow of our product and to get the most shear forces introduced into our mill base. So you can see that table on the right where you see the different vessel sizes and then the optimized dissolver blade diameter, and there is always a sweet spot, and it changes depending obviously on the type of material dispersing and so on. So this here is the critical calculation to figure out our tip speed. So the tip speed velocity is calculated by pi times the diameter of my milling disc times by the RPM. And then if you want to do meters per second, you divide the whole thing by 60. If you use metric, so the diameter of the milling disc, so 0.05, it's 50 millimeters, for example. And then you divide the whole thing by 60, and then that will give you the speed in meters per second. That's one of the most critical values in the entire dispersion process, so you may want to write this down. The second really critical part is the visual cue. So what happens when I look inside on my vessel as I'm dispersing? What do I see? And ideally, you want to see a donut that looks like that. So when I see this, I know based on the way that the mill base forms and shapes, I'm optimizing now my dissolver batch, and I'm really putting in enough energy to really properly break up these binding forces. So when you see that, you're on a good path to a very good predispersion. What happens there is basically we're introducing all the shear forces with the blade, and these teeth on my cow's blade are responsible for these separations of these binding of the particles and breakup of these binding forces. So it actually happens right on the corners of my blade and also on top of my blade and also on the bottom of the blade somewhat is where I'm actually seeing most of my shear forces, and that's where the breakup of these binding forces occurs. So if I look at this picture right here, you can see we're operating about 21 meters per second, which is optimum for my predispersion step. And we're putting in about 850 watts of energy into our mill base. Beautiful batch, looks great. It's going to give me really good results. But if let's say I go and maintain my tip speed, but I'm reducing the amount of energy I'm putting in. Now I don't see a really nice donut anymore. I see product getting splattered around and it's not moving properly. I'm not optimizing my dispersion process. Therefore, I need to put in more energy to have a better looking donut and get an improved dispersion results. So here is an example of where we just put way too much energy into a mill base by maintaining the same tip speed, and now I don't have also a donut because everything is bouncing all over the blade. So that's also not optimum. So you really want to dial it in and use the right amount of energy with the right tip speed to really have this proper donut. Now, there are some cases where we have seen where, for example, the viscosity is very low to begin with, where it's also difficult to really achieve a donut on some applications. But for most products that we see between 1,000 and let's say 10,000 centipoise, we should really be able to have a nice donut shape if we optimize these dispersion parameters that we just talked about. So here is just a calculation on the mechanical power. So you want to put that, write that down. And basically, we want to optimize the dispersion result. So we want to look at the length of how long are we running our dispersion process. Do we have a donut effect? That's important. That's the visual cue. Our tip speed, again, between 18 to 25 meters per second. It's really important. We get calls all the time. People they buy inexpensive mixers and they don't, with low RPMs, and they have very small diameter discs, and they're like, why am I not getting a proper dispersion? Well, the problem is you don't have the right tip speed, and you cannot get the right tip speed if you're only using a mixer. There is a big difference between mixers and dispersers. Mixers are much cheaper, but they don't give you the high RPMs that you really need to get that tip, to get that dissolver disc into that tip up to that tip speed that it needs to be between 18 to 25 meters per second. If you are hovering around anywhere between 6 to 8 to 10 meters per second, you may never reach a proper dispersion, or it will take you much, much longer to really get the particle size reduced to where it needs to be. So always look at that and understand that mixers and dissolvers are not the same thing. So they're different pieces of equipment, and also their costing is different. So mixers are usually much cheaper than a proper dissolver. So be aware of that when you make purchasing decisions. Geometric considerations are critical. Obviously, we want to always make sure that our dissolver blade is not too small or too large. That will impact our dispersing result. And also, if my blade is too big or too small, I will not get a proper donut, and therefore it's not being optimized. There is also the different types of dissolver discs on the market with different teeth configurations, also different materials. So you always want to make sure you choose the right disc for your application. The amount of mill base is critical. You don't want to go, if you have a 1 liter container, you don't want to go up 900 mil because you're going to spill your product. So the rule of thumb there is usually 50% of fill rate of your container vessel. Maybe you can go up in some cases up to 70%, but you shouldn't really go much higher, or you're going to really start spilling the product if you turn up the RPMs. Pigment and filler concentrations are really important, obviously, to get good dispersion result. We want to keep our temperature as low as possible. We have double-jacketed vessels. It's not as critical in our pre-dispersion stage as it is in milling, because in milling, when I use media, I introduce a lot more energy. So therefore, I have to manage my temperature much more carefully, so it doesn't go above a certain threshold where it could affect my material instability and also hurt my pigment and destroy my product. We have seen that, so cooling is important. And then obviously the type of additive plays a role for better wetting, dispersing effects, and flocculation. Keep that in check with the proper additives. And then if I want to go to primer particle size, we really need to use a bead mill to achieve that process. So just to show you the difference between the two, so they're both important. You cannot mill without using a dissolver first because you will clog up the screen in your mill. You're not going to be efficient. The particles are going to be too large. And if you use small beads, you don't have enough kinetic energy to really break up these binding forces. So it's a critical step to always use this dissolver first in your dispersion process before you use a bead mill or any type of milling equipment. Whether it's horizontal, a back inversion mill, or a 3-roll mill, you should always use a dissolver first. Again, with the dissolver, I have only a cow's blade. So the amount of energy that I'm putting into my mill base is somewhat limited by that. So I have much higher energy input with the bead mill than I have with the dissolver. That means also my shear force is reduced, and I only deagglomerate with my dissolver. I do not go down to primary particle size, because we get calls a lot. The customers say, I bought this dissolver, and why am I stuck at 20 microns? Well, that's because of the shear force limitations. That's why you're stuck. So you would need to continue the process with a media mill. It's critical, again, for every dispersion step to first use a dissolver. And then if I only use a dissolver, obviously my particle size is large, and therefore my color strength is limited, my gloss will be reduced, and I have other appearance issues if I don't do the media milling. Okay. Lab dissolver types, for example, right here, they should go up on a very small scale to 20,000 RPMs, because if you have a very small diameter blade, you need the higher RPMs to really give you that tip speed between 18 to 25 meters per second, what we talked about. With the VMA modular design concept, we have a variety of different accessories, different tips that you can add on. We can also add on a basket mill onto the same type of equipment. So you are very flexible with using a VMA disper mat. So the disper mat allows you to be basically very universal. You can use them as a homogenizer, as an emulsifier, by adding a rotor stator, for example, or just as a true disperser with the cowls blade, or adding different type of milling discs, or even a basket mill if you want to. So if you look at this slide right there, you can see we have the standard dissolver in the middle, and then all the different attachments that can be purchased to go right on the same machine, making it a very universal tool for all your dispersing as well as your milling needs in your lab, or even in manufacturing. We have the same modular capability that we're very proud of offering. So for a small laboratory scale disperser, dissolver, we can go down very small to 0.05 liters of volume with the smallest member of our disperser family, the LC. Here you have just a very simple operation with just the speed indicator and the timer function, not really anything else. You manually lift up the motor along the shaft at the stand, and it's no bells and whistles really with this model. There is an explosion-proof version available, so if you're doing a lot of solvents, disperse those, you might want to look at having an EX model. So the next type of dissolver that has a little bit more capability for us is our CD line. There we have a little bit more functionality in terms of our readouts. We can see our torque value, which is important to some customers because it tells them about the viscosity or the state of the viscosity of their product. We have also the speed indicator, obviously. We have a temperature readout, especially if you want to use this piece of equipment to do milling. Then we have a PT100 probe that will work with it, and also a timer function, actually a dual timer, so we can set it up to disperse your product for, let's say, 30 minutes. And then after 30 minutes, it could reduce the power or the speed, and then run for another 30 minutes at a reduced speed. So that's a really nice way of modifying your dispersion process. And then I want to mention that all of our dissolvers really are equipped with these safety features. So we have, and these are very important, so we have a container clamping system that you can see right here that will allows you to tighten the container clamp to make sure that, number one, the container is always in the center, and number two, that it's fully locked in place and it doesn't wiggle around. So that means on the display it will show you if it's not locked in properly, and the dissolver will only power on if the sensor detects that it's fully locked in place. Secondly, very important is our working area threshold. So we have a magnetic slider. You can see that on the side of the shaft right here on the stand, where you actually slide that slider up or down to select the threshold when you want the machine to power off if somebody were to lift up the shaft while it's running. So that means you're safe. There is no blade that's spinning outside of the container. Nobody can get hurt by sharp edges of the couch blade, and there's also no product flying around your lab. And then all of the dissolvers come equipped with a shaft protection pipe that's right here that you can slide up and down, secure it with that nut to ensure that there is no moving or rotating parts, the shaft, for example, outside of the container. The next most popular line for lab and pilot scale is the CN. Same motor design as the other models, bigger stand configuration. And here we have the ability to set that working threshold, that safety feature digitally on the display, so we don't have that magnetic slider, so we do that right here on our control panel. And also electric lift motor, so up and down to move the motor up and down electronically, not by hand. And the CD will also do that electronically, not by hand as the LC. And then we'll make those CM models again for pilot scale, same type of concept in terms of the control capability and readout, but for larger volumes, we can go up to 150 liters with our largest CN model. And then we have the premium model dissolver, which is really nice for people that want to be in an environment where they want to log everything. They want to do, store batches in a database, give different products a name and store them. And with this device, you can store all your data in here, and we call it at a later time, and then run the process exactly the same way every single time. It's really important for upscale because I can store all my data. I see my tip speed on the display. I see all the critical dispersion parameters on my display, my temperature, my torque reading, my timer function, energy in watts that I'm putting into my mill base. So I can also run this dissolver not only with a certain speed setting, but I can also run it with a certain amount of energy. So that means if I put in 500 watts of energy into my mill base, then my machine will automatically adjust the speed depending on the viscosity change to always maintain the certain amount of energy that I'm putting in. So if my material gets more viscous, my speed will drop because I'm maintaining the 500 watts of energy, for example. So this is also nice because I can precisely calculate now my manufacturing costs because I know for this product, half an hour of dispersing, I need this amount of energy. Therefore, it's going to cost me X amount of dollars to produce this product in my manufacturing plant. So these are excellent tools for R&D and upscale if that's something that you're looking for for a dissolver. And it stores all these critical parameters. And also, you can send the data over to a computer and watch the entire dispersion process in real time on a computer screen. And I'll show you that when we talk about the QC parts a few slides down. And then we also have the larger AE for pilot, same as the CN, same capability as the AE, the smaller one in terms of storing the data or constant power. I can also do what's called a net power calibration so that the machine will only display the actual energy it's using to disperse the product, because the machine itself will use energy to run itself without any material. So the motor will use up power and energy. So when I do a net power calibration, I factor out all these values and really only show what is the energy required to disperse my product. So that's also very important when I want to go upscale, to have that net power calibration feature on the AE model. And then again, we can go up to large volumes, and we have EX models available as well if you're in an explosion-proof environment in your lab or your production or pilot area. And then for manufacturing, we have the same type of capability. For our dissolvers, we can go up to 2,000 liters. You can also fit this particular piece of equipment with what's called a quick change system, which is very unique to the VMA product line, which means it also allows you to attach a basket mill or a rotor stator onto the same dissolver. So you only need one piece of equipment for all your dispersing and milling needs instead of having to buy two pieces of equipment for your manufacturing area. That means I have huge amount of space savings, maintenance costs are reduced, and I'm just handling the entire process on one machine rather than having to move my container in between different machines, as a lot of these older style manufacturing facilities where you see one room they have dissolvers and in the other room they have all milling equipment. With this type of technology, it allows you to do everything on one piece of equipment. So the cost savings are huge, and especially if I'm running, let's for example, multiple colors, different color families. What customers are doing is they buy additional milling baskets and then basically they swap out the baskets depending on what color family they run. And that means they can do a color change in less than 2 minutes, which is really, really good because we all know how much time gets wasted cleaning these machines and you know, having a proper machine on the next batch of color. We also have vacuum capability as for our lab dissolvers as well as for our larger manufacturing or pilot units. And that allows us to really draw out the air. We have seen some improved wetting and dispersing effect. You imagine these air bubbles that are trapped inside of your mill base, they act like tiny little air mattresses. So by removing that, I'm removing those buffers. So I have more, the energy that I'm putting in is more direct. So I have a much more efficient way of dispersing my material. I can put in more direct energy. I'm also getting rid of all my foaming. Especially when I want to do my product transfer. That's an issue for a lot of customers is what am I going to do? There's so much foam in there, especially with my waterborne formulations. That's not so much with solvent, but if I have the ability to dry vacuum, I get rid of all my bubbles and foam, and I have a much more efficient and smooth product transfer, which also will translate into better homogenization of my product and also obviously a cost savings because of speed. And always, I don't need to put in as many raw materials. Some customers, for certain applications, want to have a nitrogen purging valve, so that's also a possibility that you could add to any of these dissolvers. Important in QC, so we want to have as much data as possible. So we have different type of control panels. So on the left, this is our new control panel. It's called the C technology panel, and there you can see on top left we see the RPMs right there. Below we have the amount of energy we're putting in, so we can run the dissolvers either by a certain amount of speed or by the amount of energy we're putting in. Then on the bottom left we see our torque reading. We calculate that value through the frequency converter, measuring how much energy we're putting into the mill base. And as the machine is drawing the energy, it needs to move the product. The torque value can change depending on my viscosity. And then on top here, I have my critical tip speed value, which is really important also for upscale. I have a temperature readout, and then on bottom, I have my timer function that shows me how long I have been dispersing my product. On the right here, this is a more simplified control panel. Here, not the C technology, this is called the CN3 technology. It's just very simple RPMs, and then I see the temperature readout and the amount of amperage the machine is drawing during my dispersion process. And then some customers like their own control capabilities. So there is a Hitachi Siemens control panel that allows you to put in your own process parameters and control capability of the production scale dispersion. So here you can see some of the important values that I can program. So I can give all my products different names or store them by product numbers or batch numbers. And then I can put in all my values, store the data, and next time I'm running my process, I just recall it, and it's doing it exactly the same time every single time for producibility and repeatability. I can put in cutout values. So if my temperature goes over a certain point, I'm able to say, okay, I want my machine to either power down or run at a different speed. Or also if I see, for example, the amount of energy that I'm putting in is too high. I can't put in a cutoff value to say anything goes over 1,000 watts of energy that it draws. I wanted to reduce my speed as an example. Or you could put a speed limitation. If you're running with constant power and the speed goes over a certain point, you can put a cutoff value in there and say, I don't want to run more than 5,000 RPMs. So there is a lot of capabilities on how you can design your experiment or your production process with the C technology. And then on the bottom, you can see the graphical interface, how you can see each of these values in all these indices in a real trend line and see if there is any problem that would appear that you need to intervene in your process. With the new software, we can also send the data over to a cell phone. We are working on that, and we'll have that capability available hopefully by the end of this year. Here's just a quick slide on the net power calibration, where we flatten out that curve to make sure that we only show the actual power that we use when to run our product and not including the power to run the machine. And then here is the software. This is actually the older Windows 7. We're working on a revised software package right now, completely new, where a new interface where we're able to control the machine from a PC. So if you are not directly in the lab, you're outside, you can run the machine from there, and then also see all the curves and lines on the graph to make sure that you're maintaining good integrity in your dispersing process. Here is our lab in Germany. We have a lot of different capabilities from different dispersing on the vacuum or with rotor stator. We also have different types of milling equipment, and we have the same lab at VMA at Big Additives in Wallingford, and we're just adding new equipment this month to have all the latest capabilities there as well. So if you like to come up to do a trial, we have fantastic facility. We'll help you to do upscaling experiments. We can do proof of concept. We're able to show you different types of equipment, how it would perform with your product, and also use the Big Additives experts to help you modify and improve formulations. So if you have questions there, we can also be of assistance. We don't want to be just a company that sells a piece of equipment and hardware and say, here's a dissolver or a milling piece of equipment. No, we want to really be there for a customer to guide them through the entire dispersing and milling process and help you achieve better results and also make a better product that helps you save money and sell more to your customers. That's the ultimate goal. And we have the facilities and resources to do that. So I will open up the panel if anybody has questions about the dispersing process. Thank you. Hello? Hello?
Hi.
I cannot hear you, John. Hello?
Andy, we're here, Andy. I think we're just waiting on John to collect the questions.
Oh, okay. While John is collecting the questions, so if anybody is interested in looking at the different types of products, dispermet.com is a great resource. You can go on there We have all the different laboratory and pilot as well as manufacturing types of dissolvers, different types of milling equipment is up there. We also show you the different types of vacuum dissolvers and other capabilities that we have. Many different types of accessories that we have up there, different types of containers. We have, very small containers down to 250 milliliters, and then all the way up to 2,000 liters. There's many different configurations. Also the types of materials. Some people, when, especially with milling equipment, they don't want to just use stainless steel. So we have options with different types of ceramic or different grades of steel. So we offer the silicon carbide, which is the black ceramic, which is very hard and also really good for high temperatures. And then obviously we use the zirconium products, white ceramic. Some customers are afraid for color changes because when you're milling in a horizontal mill, for example, if you use stainless steel, that could turn your product gray very fast if you're trying to process TiO2. And with that capability, we're able to do many different types of milling, for many different types of milling applications.
Thanks, Andy. Can you guys hear me now?
Yes.
Okay. Not sure what happened there. Lost my connection a bit. But anyway, yes, we will be sending out this recording following the presentation. Actually, probably tomorrow morning. It'll be out there for your review to capture any of those formulas or measurements or just any of the information. Also, if you have questions, you can respond directly to that email. We'll get them to Andy directly. And two, we still have some time for questions here. If anyone would like to enter them in the Q&A box, how can we help your dispersion efforts? And, or some of the challenges you're experiencing at your own facility, let us know. We'd be happy to help here. Andy, are there frequently asked questions that you get, over and over that would help our attendees today?
Sure. Well, there's many questions we always get, but one of the most important questions that customers ask when they hear about this format, because some customers are not familiar, they always wonder how can you make a change from a dissolver disc over to, for example, a basket mill. And we have a special design, so it's this called a bayonet style system, where on top of our shaft we have a clamping system, and it basically allows you to remove the dissolver shaft and replace it with the basket mills or vacuum system by just turning this. You open up the clamping ring and then you turn the shaft assembly 180 degrees and you pull it out from the under the motor flange, and then you just replace it with the basket mill. And then you put it back in, turn it 180 degrees, put the clamping ring back on, and you're up and running. And now you turn the dissolver into a basket mill or a bead mill, for example. So that's really unique to the BMA Getzmann Dispermet line. That's the design philosophy that Herman, when he started the company, envisioned. He always felt that, laboratory space is very scarce. And we want to do as much as we can on one piece of equipment and not tie up unnecessary, lab space with additional equipment if we don't have to. So having that capability saves customers a lot of time and money and space, obviously.
Excellent. It definitely feels like April Fool's Day with these technology issues today. I just thank you for attending, everyone. We appreciate your time and look forward to future invites for web seminars. In about a month, we will be switching webinar platforms. So some of those technical issues that we have here and there should be eliminated, hopefully. So stay tuned for that. Thanks for your patience there. Have a great holiday weekend. Look for the recording coming tomorrow morning. If you have any questions at all, please reply, and we'll get them to Andy and our field team to assist. So with that, thank you for your attendance. Andy, thank you for your expertise, and everyone have a great afternoon.
Thank you, everybody. Hope you have a good weekend, and look forward to hosting you at the second part. John, when is that second milling seminar, part 2? Do we have the date?
Yes, it will be included in the link with the recording. I'm looking up the date right now. It looks like I don't have that handy right now, but it's coming up in the next 4 to 6 weeks. So look for that, and it will be highlighted in that email you receive.
Okay, great.
Okay.
Look forward to seeing everybody again when we have the second part of the Dispersion seminar.
All right. Thank you all. Have a great weekend.
Thank you.
Thank you. Nicely done, Andy.
Thank you very much. Bye.